So some products that you put through this pump are quite harsh or cause premature wear on the packings. Products with calcium silicate, products with macacious iron oxide, aluminium oxides, they all have a significant wear factor in relation to the longevity of the packings themselves. The other indicator is, of course, not only did I mention paint escaping from this gland nut, but also too you'll see a significant drop in pressure. So how can I ascertain what the drop of pressure is? Well, predominantly what you'll do is when you're spraying, you'll see the drop in pressure because the atomization from the tip to the surface of the material itself becomes diminished in the sense that the dry spray tends to follow the spray tip pattern. Also too, you'll have an undulating spray tip pattern. So when I say undulating, it'll come in and go out, come in and go out. That's indicative to ball wear as well, which is top and bottom, your primary ball, your secondary ball. So all of these factors are relative to wear within a pump itself. Primarily though, most of you would have experienced paint coming from the top of this gland nut. So that being the case, you can, with no pressure on the pump, increase some torque with the C-section spanner on this gland nut to try and torque it down a bit more to create a bit of squash on the packings, to reduce the bypass of product out the top of the gland nut. If you're unsuccessful in that and you've lost pressure, you can see that you have poor atomization. Ultimately, you need to replace the packings within the pump. So to give you some idea of how to do this thoroughly and correctly, what we're going to do is remove sections of this and remove the pump from the housing of the entire body itself. So primarily what we'll do is we'll make sure that there's no thinners in the suction hose, which goes into the material itself. So we've removed that. You'll have some runoff here, so it would pay to put a piece of rag or a container underneath the machine to catch that escaping solvent. So what we'll do is, as I mentioned yesterday, we have a knockdown section. So from here down to here is a knockdown. So we can use a hammer or you can use a pair of Stilsons. So on site, you'll find predominantly you just have a hammer. So we'll undo this and remove this suction hose. So you can remove the suction hose out of your way, which exposes the foot valve of the pump itself. The retainers here are 3 stem bolts with nylock nuts on them, and you have a linch pin in the top, a cover, and the collets underneath that. So ultimately what we're going to do is we'll put a support timber underneath the pump itself so that we can support it. So by putting a support under there, that'll hold the pump in position for me. Now, I know there's no pressure on the pump because I can operate the dump valve. There's no pressure. Pull the trigger on the gun, no pressure, so it's safe to do so. So just to run through that again, before I do anything with this pump, I make sure there's no pressure in this chamber. So to ensure that there's no pressure in the chamber, open the dump valve, pull the trigger on the gun, no pressure. So now that I have no pressure in there, it's safe to dismantle the pump. So the first thing we need to do is take the hose off the pump itself. So by removing this nut here, now if there was pressure on that, that would be very, very tight to undo. So if the pump was pressurised, you wouldn't get that undone. So you can see there's some remnants of solvent there. Just ensure I catch that as best I can and remove the whip check that we had on the hose previously. So now we've done that, we don't drop that in the dirt. Best to put another blank fitting in there or put this up so that it can't be exposed to dirt and contaminants. So with this weeping off beautifully, what we can do is undo these retaining bolts, which are, as I said, nylock nuts. So you'll find that because they've been done up for some time, they'll have paint accumulation around the threads. You need to crack them